Today we're going to practice finding exact sine and cosine values of some of our special landmark angles or locations as we move around the unit circle. Okay, we've seen in the past that when we think about a coordinate on the unit circle, the x-coordinate is always the cosine value of that angle, and the y-coordinate is always the sine of that angle. Another way to think of that is if sine is the y-coordinate, then we're really talking about the height of the triangle. And if cosine is really the x-coordinate, then we're really talking about the base of the triangle. And thinking about these triangles will continue to be useful today. So let's take a look at a series of 4 examples where we have to find a sine or cosine value of a given angle. Now I know you could really just look at your unit circle at this point and go find the y-coordinate of 270 or go find the x-coordinate of 120, but let's use this as an opportunity to really practice visualizing where we are on the unit circle and what that triangle looks like. And let's try to use words like quadrant. Let's try to think about what quadrant we're in. Let's try to use the word reference angle, trying to think about that angle formed with the x-axis. And let's really be focusing on our 3 special triangles. Are we talking about the tall triangle, the short triangle, or that in-between isosceles triangle? So I'm going to zoom in a little bit here, and let's take a look at sine of 270 degrees. So really all this problem is asking me is, what is the y value at 270? So the first thing I should do is figure out where is 270 located. And so that work we did of locating angles or labeling angles on the unit circle should help with that. 270 is 90 degrees past 180, so that puts us on the negative y-axis. And now that we know where we are, we can think about what would the coordinate look like there. And in this case, it's not a triangle at all. It's really just a coordinate where we did not move left or right, but we did move down 1 because the radius is 1. So here we go. The y value is negative 1, which means the sine of 270 degrees is negative 1. Sine is just the y value at that location. Let's take a look at a couple more where triangles might be useful. So now we're trying to find the cosine of 120 degrees. So first we need to think how cosine is really the x value or the base of the triangle formed at 120 degrees. So again, let's first locate where is this angle. So picturing starting over here at 0, I would need to go past 90 to get to 120. I'm essentially stopping when I'm 60 degrees away from that x-axis at 180. And so 120 degrees is up here in quadrant 2. Since I'm 60 degrees away from the x-axis, that's my reference angle. This is a reference angle of 60 degrees. So now I can say to myself, I'm talking about the tall triangle in this problem. And so the tall triangle is the one where the base is the shortest of all bases, 1/2, and I put a negative there because I went left in this case. And then the height of that triangle is the tallest of all of our special heights, which would be square root of 3/2. But all I really needed in this problem was the x-coordinate, the x value, and so here's my answer staring at me right here. The value of cosine of 120 is negative 1/2. It's that base or that x value when I'm at 120 degrees. Let's do 2 more. Okay, so now here's one right here, sine of 315. So again, going back, thinking about sine, my target in this problem is to find the y value or the height of the triangle when I'm at 315 degrees. So again, let's locate where that is. 315 is just a little shy of 360, which would have been all the way around. And specifically, I'm stopping 45 degrees short of 360. So 315 degrees is that middle halfway through quadrant 4. So I know I'm located in quadrant 4. I know I'm talking about a 45 degree reference angle, that angle with the x-axis. And so this is that 45, 45, 90 triangle, the isosceles triangle. And the nice thing about this one is it's the one where the base and the height are the same. They're both root 2/2. The only thing I did here is I added a negative because if I'm down, I'm talking a negative y value. And so now I can answer the question, sine of 315 degrees is negative root 2/2, which is just the y value or the height of the triangle at that location. And then one more just to get radians back on the table. This question is really exactly the same, maybe just a little more work to kind of translate and think about radians instead of degrees. So if I ask you for the cosine of 7 pi over 6, I'm really just asking you what is the x value or the length of the base of the triangle if I'm at 7 pi over 6 radians. So you could either do some work to convert to degrees, that would give you 210, or we could think of how halfway around the circle is pi, which would be 6 pi over 6, so just a little bit more, 30 degrees farther would put us at 7 pi over 6. And now I know I'm talking about an angle located in quadrant 3. The reference angle is 30 degrees. I'm 30 degrees past the x-axis. So in this one, I'm talking the short triangle when I think about our special triangles. And for the short triangle, the height is the shortest of all the heights, 1/2. I put a negative because it's down. The base of the triangle is the biggest base, which would be the root 3 over 2. Again, I added a negative because I'm left. And now I can answer my question. I'm looking for the x coordinate or the base, which in this case would be negative root 3 over 2. That is the cosine value of the radian angle 7 pi over 6.